Okay, so here is 7th grade Unit 3 test corrections. So make sure you, the deal is you have to correct every single problem. Okay, so looking at number 1, it says an air conditioning technician charged $77.25 to repair his air conditioning system after 3 hours of work. The technician charged the same rate for each hour of work. Which diagram represents the constant rate of change? Okay, constant rate of change is your constant of proportionality. We're looking for same hour, constant rate of change, and then he did $77.25 to repair his air conditioning system for 3 hours of work. Okay, so if we write that, we're going to say 70, I need to go back to a pen, 77.25 for 3 hours of work. So 77.25 for 3. So that's really, we need a per hour charge. Okay, so this is going to be for 3 hours. So looking at these diagrams, this is saying that 77.25, and then this is breaking it into 3 hour increments. So a total of 3 hours each time at 25.75. And that's not really what it's saying. It's saying 77.25 for 3. So if we found the hourly breakdown, it would be $25.75 per hour. Okay, so looking at this is $25.75 for 3 hours, and so that's not going to be our answer. B says $25.75 for 1 hour, and that's really kind of what we were looking at, and $77.25 for the total. I think this is probably it. This is saying $77.25 for 1 hour, and then $77.25 for the whole 1 hour, 2 hours, so $77.25, and 3 hours is $77.25. This is saying $77.25 per hour, so we know it can't be either of those two, so B is our answer choice there. Number 2, it says the table below shows the time it takes a prototype car to travel different distances. What is the constant rate of change for this situation in miles per hour? So I'm going to write that wording, and I'm going to say miles. Man, I think I switch it and it's not. Okay, I'm going to write miles per hour here. Okay, so if you look, we have this in minutes. So we've really got to think about this. So can I change it to miles per hour, or I needed to change it to miles per minute? So we're going to have to convert this hour to minutes. So I'm going to change it to minutes here, okay? And then I have how many we're looking for an hour, right? So this is our words. Our known is something, and our unknown is we're looking for 60 minutes, because that's what equals 1 hour. So I'm going to look for something easy to convert it with, and I'm going to see either 15 converts to 60 easy or 30. Let's go 30, okay? So let's go this 30. So at 30 minutes, it's 27.5 miles. Okay, I can just scale up right here. So 30 times 2 is 60. So 27.5 times 2 is 55. Okay, so 55 miles per hour. Okay, number 3. The battery reading on Seth's tablet is shown in the table below. A full battery is 10 units. What is the constant rate of change for the table's battery reading? Okay, so constant rate of change is going to be that unit rate that we're looking for. So constant rate of change. I'm going to look for a unit rate. When I'm looking at the wording, I'm thinking unit rate would be, this is in time, so an hour is what I'm thinking. So we're looking for the change per hour. Okay, so come back in here. Okay, change per hour. Okay, so if you look right here, 8:35 to 9:05, that's 30 minutes. Okay, this is a 15-minute increment, and this is a 45-minute increment. Okay, so if I'm looking for a true hour, I could go 9:05 to 10:05. So what's the change from 9:05 to 10:05? Because that's really 1 hour. And it went from 1, 2, 3, 4, 5, 6, 7.5 units to 1, 2, 3, 4, 5.5 units. Okay, so the change there, it dropped 2, so it went down -2 in 1 hour. So if you look at answer choice D right there, it says exactly what I didn't mean to pop that up to say. Okay, number 4, Haley bought 1.6 pounds of almonds for $13.20. How much did she pay per pound for the almonds? Okay, so we're going to write a words known unknown for this. So we're going to say cost per pound is going to be our words. Our known is going to be $13.20 for 1.6 pounds. And our unknown, which we're really looking for a unit rate, is going to be the cost per 1 pound. So if I put an X there, I can't scale down very easy, so I'm going to cross multiply. And I'm going to say 1.6 times X is 1.6X. And then 13.20 times 1 is 13.20. Now my next step is I'm going to divide both sides by 1.6. So I'm going to come over here. I'm going to move my decimal outside, inside, up. And I'm going to put C7. It's going to go 8. Let me see, 8. It's going to be 2, and then 5. So $8.25 per pound for the almonds, which is answer choice G. Ken was pricing ingredients for a recipe he was planning to make for the dinner party. The store sold 4 different brands of the same type of product. Which statement about the unit cost of the different brands is true? So we're looking for unit rate. So it's cost and then ounces. So we're really looking at the price per ounce, and you're going to have to find them individually. So $2.88. Okay, for 8 ounces. So that's going to be my first one. So for 1 ounce, so 288 divided by 8. It's going to give me 36 cents an ounce. So brand A is going to be 36 cents an ounce. Brand B is going to be $1.44 for 4.5 ounces. So how much for 1 ounce? So we do $1.44 divided by 4.5. Outside, inside, up. And then it's going to go in here 3 times 135. You're going to drop down 9. Add a 0, drop it down. 45 goes into 90 2 times. So it's going to be 0.32. So brand B is 0.32 cents an ounce. Okay, brand C is going to be $1.84.05. How much for 1? So it's going to be 180 divided by 5. 3 times 5 is 15. Drop down your 3. 5 goes into 36 times. So it's also going to be 36 cents an ounce. And your last one is $1.20 for 4 ounces. How much for 1? And $1.20 divided by 4 is going to be 30 cents an ounce. So now let's look at our answer choices. It says brand A, brand C has a lower unit cost than brand B. Well, brand C is not lower than brand B, so that is out. Letter choice B, brand D has a higher unit cost than brand A. No, brand D is lower than brand A. And then C, brand A and C had the same unit cost. A and C, same unit cost. This is a true statement. So C is our answer choice. Okay. Number 6. It says, the figures below are similar right triangles that have a proportional relationship between the base B and the height within each triangle. So, what is the constant of proportionality that relates length of base to length of height? So most of you, if you missed this question, it was because we didn't do the right, we did height to base instead of base to height. So you're talking about base to height. Okay, and so right here, this is our base, 4.5 to 1.5. So if we just divide that, 4.5 divided by 1.5, you're going to get 3, which is answer choice H. And then number 7, Tim's mom filled the gas tank in her SUV and spent $72 for 22.5 gallons of unleaded gas. What is the constant of proportionality that relates the cost in dollars, Y, to the number of gallons? Okay, so it tells you exactly how to write the proportion. It says cost to gallons. And so really we're looking for the constant of proportionality, which is your unit rate. Okay, so 72 over 22.5. How much for 1 gallon? So in essence, you're dividing 72 by 22.5. So outside, inside, up. And we're going to get 3 times there, which is 675. And then 2545 is going to be left over. You're going to add a decimal and a 0 and drop that down. And 225 and a 450 goes exactly twice. So 3.2. So that's dollars and cents. So it's going to be $3.20. Okay, this is going to be in the first video, and then I'll have you come back and pick up for the next video.